Hey Cascadia, and welcome to this wild TypeScript safari. My name is Daria Caraway, and I'm going to be your safari guide today. I am a senior UI engineer at Netflix, and I have been an avid lover of TypeScript adventuring since about 2014. Now, although I have quite a bit of experience with TypeScript, I'm just going to be honest and let you know that I know absolutely nothing about jungle animals. I am not qualified to be a safari guide. So this is not going to be a geographically accurate safari, but I think we'll still have a good time. So today we're going to be going on an expedition because working with TypeScript can sometimes feel like you're on a jungle safari, but instead of animals, there are types. And maybe you've been down a code expedition like this, so picture it with me. You start off in your TypeScript code, you see some incredibly helpful small types. The sun is shining, the types are keeping all of the bugs away. You're moving so quickly down this code path, you feel like you could take on anything in the web development kingdom. So you start to meander down some more difficult terrain, the types are getting a little bit bigger, a bit more poisonous, so you start to slow down, identify these types, really get to understand them because they're getting kind of intimidating. But you keep going down further and further on this code path until the path gets a little bit darker, it's harder to see, there are these scary types up in the trees, but again, we can do this, you keep going. Until you come across this absolute monster of a type. It's a Jaguar type. This thing is so big and so scary, you have absolutely no idea what it's going to do. So you turn around and run away as fast as you can because let's be honest, you don't know how to take on a Jaguar type. And you run back to that nice trail where the sun was shining and the birds were chirping, surrounded by nice, small, easy types where you stay right here in your TypeScript comfort zone. If you've ever had an experience like this, there is good news. Just like jungle exploring, probably, TypeScript gets easier and less scary with practice. So today, I want to be your guide on this TypeScript safari, where we're going to break down some of the scariest types that I found out there in the wild, in the real world. I've adjusted the types a little bit to make for a better story, but for the most part, these are real types that I found on Definitely Typed or in documentation for various libraries like Lodash, even React, and in the TypeScript docs themselves. Hopefully, at the end of our explorations, we can make it past these intimidating types to the beauty on the other side, that is TypeScript. So let's start off on this journey. We're on this trail, we're further away from the crowds. The first type we come across is this coral snake type. And I can tell you as a safari guide that coral snakes are incredibly poisonous. At first glance, it's really long, there's lots of stripes. It's kind of hard to identify because there's so much going on here. There's a generic type, a union type, and a conditional type. So let's break down this type and identify all of the parts. First thing I want to do is just spread it out so it's a little bit easier to take in. Then let's dive into the generic. Generic types are incredibly useful for making types more generic. A generic is basically a stand-in representation for a type that will either be provided as input or inferred by TypeScript. Here, type T represents a type that is going to be supplied by the user, and TypeScript will enforce all T's to be the same type. Something that I think is important to know is that generics are often notated with a single letter. You might see some T's, that's probably the most common one, but also like K and V, maybe U, but they don't have to be a single letter. So I'm just going to fill in our generic here with a type that I think makes more sense right now. I'm just going to call it type passed in because that's what it is. Our type is truthy, takes a type that is going to be passed in. Okay, now that we've taken a look at the generic, let's talk about union types. Union types are an incredibly fundamental part of TypeScript that are used to compose other types, but can also be used on their own. Here, a union type is a type that can be either null or undefined or false or empty string or zero. So I'm just going to put those exact words back into our type to make this type read more like a sentence. When paired with extends, we're saying that we're asking if the type passed in is a subset of null or undefined or false or empty string or zero. Lastly, we have this conditional type. So much like how JavaScript has conditional expressions, you can say like if this else this. TypeScript has conditional expressions for an if-then assignment of types. Here, the conditional type checks if the type passed in extends null or undefined or false or empty string or 0, and then assigns a value accordingly, either false or true. Putting that all back into our type in plain English words, we have type is truthy. If the type passed in extends null or undefined or false or empty string or 0, then the value that this type assigns is false, because that means that the type passed in is not truthy. Otherwise, the type assigned is true, because that means that the type passed in is truthy. And what that gives us is this type that can take any other type in and tell us if that type is truthy or not. So if we were to pass in the string hi as a type to is truthy, we would get back true, because hi does not successfully extend null or undefined or false or empty string or 0. Hi is not a subset of those things, which means that hi is truthy. But if we were to pass in null, we would get back false, because null is a subset of null or undefined or false or empty string or 0. So then the value is false, because null is not truthy. And now that we've broken it down, we've spelled it out, I've gotten a little bit closer to this snake, and I can tell you that we don't have to be nervous about this snake. It's actually not a venomous coral snake. It is in fact just a harmless milk snake, which is often mistaken for the more dangerous one. But so far, we have nothing to worry about. This type, totally manageable. So, continue on our journey. Then we come across this poisonous dart frog type, which is poisonous. It's small, it's unpredictable, and there's lots of things going on here. We have multiple generics, multiple utility types, and multiple key of operators. So first thing, again, I want to spread it out and fill in all the generics. There are actually 2 generics being passed into this type. I called the first one type passed in, and I called the second one K passed in, because not sure what that line is doing yet. So let's figure that out. Here we have a key of operator. Key of creates a union type from all of the keys of the provided type. So if we were to pass in a type example type, which is A string, B number, C string array, and we pass example type into the key of operator, we're going to get a union type of A or B or C. Then we're going to combine that with extends. So we're saying that K passed in must be a subset of the strings in the union, which are the keys of the type passed in. Otherwise, TypeScript is going to give us an error. So let's update K passed in to be a better name. I've called it keys of type passed in to omit, because that's actually what's going on here. Omit takes a type that you pass in and a union that are keys of the type passed in that you're trying to omit. Okay, so now in the meat of the type, we've got some utility types. We have pick and exclude. Utility types are globally available types that represent common type transformations that are provided by TypeScript. So if you want to use these, you just can. They're part of TypeScript. Let's take a look at the inner utility, which is exclude. Exclude is a neat type that returns a type minus any of the union members that have been provided that you're trying to exclude. So here we will get a new union, which is all of the keys of type passed in minus any of the keys that we're trying to omit. So the keys of our example type were A or B or C. We're going to exclude B, and that's going to give us a new union type of just A or C. Now we have the keys that we know we want off the type, but how do we actually get back the type? That's where pick comes into play. Pick returns a new type from the type passed in with only the properties that match the keys that you've told it to pick and keep. So here we're going to get a new type by picking off all of the properties that we get back from the exclude statement as keys. We're going to pick those keys off of the type passed in and keep them for our new type. So we excluded B from our key union, and now we're going to take the output of that exclude, which is A or C. We're going to pick those off of our example type, and that's going to give us a new example type with just the properties A and C. And this is the exact behavior of omit. If we were to take our example type and say omit B from the example type, we get a new example type with just A and C. And if this looks familiar, it's because omit in itself is a TypeScript utility type. But omit wasn't added until about TypeScript, I think 3.5. So there are actually around 60 instances of this omit type indefinitely type that were likely added before omit became part of TypeScript. But if you want to use it now, you don't have to define it. It's just there for you to use. Now, once again, we get a little bit closer to this frog, and actually, it's not that scary. I can tell you now that we've identified all of the parts that this is not a poisonous dart frog. This is just a colorful mimic poison frog. This frog is really great for us actually because it's going to eat all of our poisonous bugs, but it doesn't present much of a threat to us as humans. So we're good to go. We've passed the snake, we've passed the frog, and we're going along and we find ourselves in a bit of a darker trail. We can't quite tell what's up in that tree, but we see this like kind of scary type with these bright red horns. It's a little bit concerning. Now this type, it's not that big, but it's got quite a bit going on. We have more generics, we have a conditional type, and we have these two infer keywords making up those two horns we saw in the tree. First thing I'm going to do, again, just going to break down what we already know. I'm going to fill in the generics that we know and expand out the conditional type. Going through what we have, we have type valid double object. If the type passed in extends whatever this is, then the value that we return is whatever U is. Otherwise, the value that we return is never. Now, never is actually an empty set, but you can think of it as something that just means it's not possible. And in this case, we're trying to check if the type passed in is a valid double object, and never would mean that it's definitely not a valid double object. So what exactly was going on with that first line though? So here we have type inference, and you might be familiar with type inference because if you're using TypeScript, you probably use it often. It's like when you create a const and you don't tell TypeScript what that const is. You don't tell it what type it is. TypeScript is going to take all of the context that it has from your code, and if it can, it will infer a type for that constant, and if it can't, it's going to tell you that you've made a mistake. So a similar thing is going on here. The generic type U is going to be inferred based on the structure of the type that we pass in. So if the type passed in extends our object structure, meaning that if the type passed in matches the object structure we're checking for, and TypeScript can successfully infer a type for U, then the statement passes. So if we have this object, A string, B string, and we try to see if it extends our object structure, it does, because you can see that our object has both A and B with a type. And TypeScript can successfully infer a type. In this case, TypeScript can say, okay, this object matches the object structure, and I can see that U is a placeholder for the type string. So TypeScript will infer U to be a string. So I'm just going to call the U generic something easier. I'm going to call it inferred type. So now, if the type passed in extends or matches our object structure, and TypeScript can successfully infer a type for A and B, then the value that we assign is going to be that inferred type itself. Otherwise, the value is never. It's an empty set, and in this case, that means that the type that you passed in is not a valid double object. So if we were to try to pass in the type string, we would get back never, because a string does not match our object structure. So TypeScript can't even infer a type. The type doesn't even extend the object structure. But if we were to pass in A string, B string, we would get back string, because A string, B string does match that object structure, and TypeScript can confidently say that the inferred type is a placeholder for the type string, so we're going to get back the type string. And as we get closer to this type, we see that the horns in the trees, it was actually just this beautiful rhinoceros hornbill bird. It's pretty rare to see these horns and this bird, just like it's not very common to see the infer keyword in TypeScript. But it's really, really beautiful when you do see it just for all the right reasons. Again, nothing to be concerned about here. In fact, I would say that this safari is pretty cool. We've seen a bunch of awesome creatures and now this beautiful bird. But then we move into this dark cave. And there we find this really, really scary type. It's super big. It kind of looks hungry. It's going to take your lunch hour because you're not going to have time to figure out what this type means. So you're going to have to spend your lunch hour doing it. This is the Jaguar type. It's big, it's terrifying. It makes you want to turn around, pretend like you never saw this type and just go on with your day. Which is totally reasonable because look at this Jaguar. It's terrifying. And same with this type. There's just like everything is going on here. We've got a map type modifier, a utility type, type inference, generics literally everywhere, and nested conditional types. Okay, but we can do this. We can get past this Jaguar. Just gonna fill in what we already know, take it step by step. I want to point out that we already have a couple of references to types that we've already seen. We have that double object structure matcher with the inferred type. We have exclude from our previous example, and we have type isTruthy from the first example. So maybe we already know a little bit more than we think. I've gone ahead, I've filled in all the generics that we know. I've broken out the exclude and the conditional nesting. I left one generic in K because I haven't really talked about what K is here yet. Let's dive into that. Turns out K is a mapped type. I like to think of map types similar to mapping over arrays in JavaScript. A map type will return a new type with all of the keys of the key iterator mapped to a value. So here we're going to map over all of the keys of type passed in, and we'll be assigning a value later on in the type. So if we were to have our example type and map over all of the keys, we would get a new type with keys A, B, and C assigned to a new value. Now that's all great, but what is this like minus question mark, dash question mark? This is not something that you see too often. And quite honestly, when I first saw this in TypeScript, I was like, that can't compile. Like that can't be right. What is that? That doesn't mean anything. Well, it turns out that it does. It's actually a mapped type modifier. There are a handful of these modifiers in TypeScript that you can apply over a type as you map over it. So here we're going to remove the question mark or the optionality from each property as we map over it. So if we have an example type and A is optional but B is required, when we map over it with this modifier, we're going to remove the question mark and remove the optionality and say that both A and B are now required. Neither of them can be undefined. Okay, so I've turned the map into words. For each key of type passed as required, we're gonna iterate over those. We were also using that key to index back into the type down here. So I've called that value of type passed in, because when you take a key and you index into a type object, you're going to get back the value of the type at that index. So we have everything broken down into words, but let's take an example pass at it because there's still quite a bit going on here. So in this example type, we have valid1. Valid1 corresponds to a type that is A string, B string, or null. First, we're going to map over all of the keys of this type and make them required. In example type, we only had the one key, so we're going to map valid1 to valid1 with a value to be determined. If the value of the type that we're currently on, which is A string, B string, or null, we're going to exclude null from that type because null is okay. It's like valid in this case. So we're going to go ahead and exclude it from our type. And that gives us back just A string, B string. If A string, B string extends our object matcher and TypeScript can successfully infer a type for A and B, which it can, because A string, B string matches our object structure, TypeScript can confidently say that the inferred type is string. Then we want to check if that inferred type is truthy or not. In this case, string is truthy. So then the value that we map to is going to be the key itself as a string. And what that gives us is an object where we've mapped the key to the name of the key if it's valid. Now we're going to take the keys of type passed in, index them back onto the type passed in, and that's going to give us, we're going to take the keys of type passed in, index it back into our new map type, and that's going to give us just the names of the valid keys that we had mapped to the values. Altogether, given our example type, we pass in valid1, A string, B string, or null, and we get back the string valid1 because valid1 is a valid key in this object. It successfully extends the object matcher. We can infer a type. That inferred type is truthy, so valid1 is a valid key. And now this type is extremely powerful because you can imagine if you're a library author, you can use a type similar to this to prevent your users from doing things that they shouldn't, all within TypeScript, all within the type, like not even executing any of the code. So we can have an example type that has tons of different properties on it and just pull off the keys that are valid according to our criteria. Valid1 is valid. That's the example that we just went through. Valid2 is valid because A number, B number does successfully extend our object structure. TypeScript can infer the type to be number. Number is truthy, so valid2 is valid and it will get put on our output, which is the valid keys. Invalid1 is not valid actually because it's optional. So optional means that the type can be undefined. Undefined does not extend our object structure, and then we modify off undefined. So that one gives us never, which isn't going to be pulled off when we index back into the map type. Invalid2 is not valid because it doesn't successfully extend that object structure. So we're left with just the union of the keys valid1 and valid2. And somehow that Jaguar doesn't seem so intimidating. We venture a little bit closer, we see something amazing, which is that big Jaguar turned out to just be an adorable bunch of kittens, creating the shadow of a larger cat like you're in a movie. And taking a look back on our type, we have this Jaguar. It's big, there's so much going on, but when you actually break down all the pieces, we find out that it's just a bunch of little kittens kind of like masquerading as a larger type. We get past those kittens and we see this beautiful opening on the other side of the dark cave. We make it to this gorgeous waterfall where the code is flowing and the bugs are absolutely nowhere to be seen. And thus concludes our expedition. Working with TypeScript can sometimes feel like you're on a jungle safari. There are small types, medium types, giant, big, terrifying types, but I hope in this talk that you've seen with practice TypeScript, all types can be broken down, identified, and made a little bit less wild. I hope that you can take away just one thing from this this talk that helps you on your next code safari when you run into a new Jaguar type. Thank you so much. If you have any questions or ever just want to talk about TypeScript, you can find me on Twitter always at Daria Caraway. Thanks, Cascadia.
Right, I think you might be muted.
I was muted. Thank you. The second time, once a day at least, right? I'm not a cat. So Daria's slides are linked to from Daria's AMA in the Discord and they're part of like this GitHub repo with like 8, 9, 10 talks in it. So that's pretty cool. But the question I have is, do you have any other tips for debugging complex types?
Yeah, so one tip that I would recommend, once you've kind of identified all the different pieces like we did in the talk, TypeScript is really interesting because it runs at compile time. You can't actually run TypeScript per se. You can't like add console logs to see what's going on. So instead, what I do is I take all the pieces of like a larger type, break them out into types themselves, and then I use the IntelliSense in my IDE. So I will like command hover over those smaller broken out pieces of types to see what those types are. And in that way, you can kind of like take something that's really big, turn it into smaller chunks, and then just go through it step by step to see what your IDE is telling you that that type is. And that makes it a little bit easier to understand what's going on without having to like start with something so big.
So basically the art of programming, which is breaking big problems into smaller problems so you can solve them.
Exactly, yeah. And the TypeScript in IDEs, if you have it set up, is super, super powerful. You can even use TypeScript type inference to help you out. If you don't know what a type is supposed to be, you can let TypeScript just kind of like do it for you and then look and see what that type is and learn like, why is it that way? And then break it out and learn more.
Well, that's very cool. And thank you so much for sharing that with us, Daria. And we are going to move on to our next speaker, Derek Hurley, who's going to be talking about cartography on the web. So thank you very much, Daria. Everybody, Derek's up next.